Hello everyone, and welcome to my talk on raising security awareness of cloud deployments. My name is Iosif Andrei, and I'm a Siemens employee and a master's student at TU München. Throughout my work, I was supervised by Tiago Gasiba, who also works at Siemens and is pursuing his PhD at University of Bundeswehr. This work was also done with Professor Ulrike Lechner and Professor Maria Pinto-Albuquerque. The presentation will start by covering the motivation behind the work, then introduce the context in which our contributions have been implemented, and finally present these contributions in greater detail. The second part of the presentation will focus on the empirical study conducted based on the contributions and end with a discussion on the findings. Looking at news from the past years, cloud incidents, at least the reported ones, are rising in numbers. Looking at the headlines on the left, we can see that lack of infrastructure security can arise everywhere and affect any party. Even the United States Department of Defense was affected by a poorly configured AWS S3 bucket. Furthermore, companies are moving to cloud infrastructures at an increasing pace, and the recent work-from-home revolution only adds to the pressure. This only means that the incidents will keep rising, not only in numbers, but also in impact. Suffering a data breach or having to deal with compromised infrastructure means one thing. Someone has to take the time to clean it up. Not only do we all know that time is money, but some things cannot be quantified. Compromised personal data can lead to more serious incidents, such as identity theft. Looking at the chart on the right, recent years once again show that organizations are suffering greatly from a lack of security in their cloud deployments. Not only that, but awareness is also stagnating. 2% of organizations in the survey don't even know how many security breaches they've had. As security researchers, we strongly believe that anything higher than 0% is intolerable. Part of the good that comes with such abrupt adoption is that there are solutions being actively developed for streamlining the software life cycle, especially on the deployment side of things. One of these new paradigms is infrastructure as code, which allows its users to capture in code their deployed architecture. And this comes with very powerful advantages such as version control and automation. Our work focuses on Terraform, which is one of the leading infrastructure as code solutions. Terraform has such a high reach because it's provider agnostic, being compatible with all the big names in the cloud industry. Despite its outreach, the ecosystem is still young, and this is seen in the lack of tools and security awareness of its users. For such a popular tool that can be used across all cloud providers, we believe it is crucial to provide practitioners with a way to develop security awareness and train for best practices. In terms of design methodology for raising awareness, we aim to develop a series of serious games for practitioners. By serious games, we use the definition of Clark-Abt, which defines any game that does not have entertainment as the main focus, but rather intends to educate. As a relevant example, the field of cybersecurity is already well accustomed with capture the flag events. These events are a Jeopardy-style collection of challenges in which players or teams must solve programming challenges related to security. These challenges can be both offensive and defensive. The contributions presented in this paper are defensive serious games. We build on the previous work and extend the well-known Sifu platform to accommodate programming challenges for infrastructure as code. To better understand the implementation context of our contributions, we will first briefly discuss how the Sifu platform looks and behaves to its users. Pictured is its front end, which I will now walk you through. The player is given a task description and the Terraform code snippet as a starting point for the solution. The main window is a text editor for the player to modify the starter code in an attempt to solve the challenge. A list of the files pertaining to the current challenge is seen on the left, as some challenges require more than one file. After submitting his solution attempt, the player is given two more pieces of information. At the bottom, meaningful feedback from the evaluation tools, and on the right we have the virtual coach, a mechanism which offers the player hints and engages him throughout the game. Moving on, to uncover how the platform achieves its functionality, we have a diagram that outlines the backend's building blocks. Our contributions are highlighted in the red boxes. The platform did not have any means of processing Terraform code before this work. Once a player submits his solution, it's picked up in the backend. There, the solution is evaluated in three regards: syntactically, architecturally, and security-wise. The evaluation pipeline will be covered in greater detail later in the presentation. After the evaluation, the collated results are fed into the hint AI and the player is given feedback in the form of a relevant hint. One very important detail: since we're dealing with infrastructure as code and targeting AWS as a cloud provider, we need to provide the user with a realistic simulation of real-life deployment without actually deploying resources. This is done with local stack, which allows us to have local emulations for the provider and endpoints in a way that is fully invisible to the user. Furthermore, the challenges can be evaluated faster than with actual deployment, as well as free of charge, since everything happens on the same machine that hosts the CIFO application. We implemented 3 challenges as proof of concept for the evaluation pipeline and aim to answer the following research questions based on them. How can academia and/or the industry benefit from the CIFO platform with infrastructure as code challenges? How do users perceive the IAC coding challenges of the platform, and how to assert the correctness of a provided IAC coding challenge solution? To address these questions, the presentation will first focus on how the implemented artifacts were designed, then address the empirical evaluation of it. The evaluation of infrastructure as code happens in 3 steps. After a user submits their solution, it is first checked syntactically. Terraform code that cannot be compiled will fail at this step. Next, the architecture of the solution is checked. To pass this stage, the user must create the intended resources. Creating fewer or more resources than required by the task, or misnaming any of them, will result in this check being failed. This also prevents corner cases, such as empty files, from being marked as a valid solution by the pipeline. For the third and last step, we use tfsec as a static code analysis tool. The tool scans the player code for vulnerabilities and reports on any findings. A successful solution will be compilable, meet architecture requirements, and have no security vulnerabilities. The first proof of concept challenge provides the user with an unconfigured bucket as starting code, presented in black in the picture. The solution requires the user to add the code presented in gray in the picture. The code has been truncated for the sake of readability. Throughout this challenge, the aim is to raise awareness by introducing the players to the notions and importance of authorization, confidentiality, and traceability in the context of cloud deployment. The second challenge we implemented tackles a needle in a haystack scenario where the player is given a large configuration that is missing one line of code. Here, the player is told that the Terraform code should not log the public IP of the AWS example instance. The solution is once again highlighted in gray. This challenge raises awareness on accidental sensitive data exposure. The third challenge deals with ensuring infrastructure availability, which is yet another key concern for practitioners managing infrastructure. The starter code for the player consists of a remote backend configuration for the infrastructure state. However, the state bucket is missing the option to prevent its destruction, thus potentially compromising the availability and traceability of the deployed infrastructure. The solution is again highlighted in gray. We conducted an online empirical evaluation of the platform online across 2 days in which participants were given time to try out the challenges. The participants were given an introduction to the platform and instructions on how to use it through the use of a recorded video material. To gather feedback, we asked participants to take part in a survey after trying the challenges in the form of a semi-structured interview and sharing of opinions. The survey was voluntary and anonymous, and all participants were informed of the nature of the study. We follow the definition of awareness provided by Hensch et al. And divide it into 3 areas of interest: perception, protection, and behavior. Keeping this in mind, let's look at the questions the participants were asked and what their feedback was. Here we can see the questions on the left as well as the collected feedback on the right. For example, the answer to the first question was centered around a neutral answer, whereas the answer to the second and third questions was more biased towards agreement. This points to the fact that students or fresh graduates feel underprepared when it comes to notions of the security lifecycle of software. The empirical evaluation also included some opinion gathering, and here we can see some quotes from the participants. Interactivity makes training less dull, gamified learning should be more prevalent, the user interface needs more polishing, the panels of the interface could use labels, adding links about incidents related to the vulnerabilities could boost awareness even more, and the evaluation pipeline could really be useful outside of the platform for real-world configuration, benchmarking, and helping with patching. Now, preliminary results indicate that the platform can be useful, for example, in the form of awareness workshops. Furthermore, the results of the empirical evaluation point to the fact that the challenges are well received. Further work on this topic is based on the feedback and includes the extension of the challenges into more complex scenarios, a refinement of the user interface and user experience, as well as conducting a more representative survey to assess security awareness. Thank you for your attention.